I'm Roman Maeder, Director of Parallel Computing Technology at Wolfram Research. I will talk about persistence and initialization. I will show the new 11.2 features for storing information at various locations and how to use it for kernel initialization. Good afternoon. I would like to tell you about the new feature of the 11.2 version of the Wolfram language that was released a couple of weeks ago. And it's all about persistence and initialization of kernels. So persistence is a unifying access layer on top of various storage locations where you can store values that persist beyond the end of the current session. You could think of storing something in a local file or in a cloud object, and there are others like Frontend Sessions. And another feature is that these locations are searched in a certain order, so you can set it up so that it can find values that exist locally before those global defaults and things like that. And the main use of persistent values is initialization. That's intended to replace or improve the old system of using init.m files where you put those commands that should happen whenever you start a new kernel. So there are a couple of new terms to learn. A persistent value, that's the smallest thing we deal with. Persistent value has a name and a value. And the way you define a persistent value is by assignment, as I've done here. And then when you ask for it, as I'm doing down here, then it will return that previously defined value. That's exactly the same thing as you are familiar with symbols within the language. You define a symbol, and whenever you use it, you get back that value. But as soon as you quit the kernel, that symbol is gone. But that persistent value will still be around. So the next time you launch a kernel, you don't need to do that assignment. You will immediately retrieve that persistent value. Now, persistent values are stored in persistent objects. And persistent object is described by the key, the same one that you see up there, and the location where that object is stored. Now, I haven't said anything down here. There's obviously a default location. That's the value of that variable $persistence base. And so if I ask for that persistent object, I will get it back. Now you note the difference here, up here. I mean, persistent values are like symbol. If you ask for them, you get the value. It's very difficult to do something to the symbol itself because it's like a slippery fish. Whenever you touch it, it goes away. And the way you solve it with symbols is that sometimes you use the symbol name in quotes, and here the same relationship is between persistent values and persistent objects. And each persistent object lives in a certain so-called persistence location. So if I move this up a little bit, then we have the next concept of a persistence location. Persistence locations are identified by a string, and I will give you a list of the ones we support in a minute. I mean, there isn't a lot of interesting stuff about the persistence location itself. If you look at the details, you can see that this particular local location is just an interface to the local file system. So these objects live inside your home directory. An initialization is a particular persistent value that is used to initialize a variable. So the syntax is initialization value, followed by the variable you want to initialize. You can give it in quotes, or if it doesn't have a value, you can just use the variable name or the variable itself. We'll use both. It's probably safer to put it in quotes. You can set an initialization value. How to use those, that's something I'll talk about a bit later. And finally, another use for these is, let me see, I can put this up a little bit. You can also use this technology for storing properties or preferences for your package. If you are the author of a package, most packages have certain settings. I mean, if Mathematica, you bring up the settings panel, you can configure it to your needs, and you may want to do the same for your own package. And then the question is, where do you store these settings? These settings should obviously be persistent, so they are remembered across sessions. And so one new possibility is now to store settings, preferences inside persistent values, and the recommended naming scheme is the name of the package, like the context name, followed by the name of the variable. In this case, it should be unique if you are the only one who writes such a package. Let's talk a little bit about these persistence locations or storage technologies. There is a fairly large number of those. I mean, first of all, when you start thinking about it, then maybe you can think of only one, namely at the low end, the symbol itself, which isn't really persistent because it goes away at the end of the kernel session. And on the other end, you could think of storing things inside files, and that means usually they will live on forever. But there are a couple of other possibilities. So for each persistence location, the important things are the scope, where do you see those values, and the lifetime, how long do they actually persist. And symbols obviously are limited to a single kernel session. You can assign symbols that creates it if necessary. You can ask for the symbol's value. And you can find out whether a symbol exists by using name queue, and you can get rid of it by using remove. And so in one form or another, these operations are supported for all these persistence locations. Although this seems trivial, it's a very useful test case. I mean, one problem with persistent objects is that they are well persistent. So, you know, if you put some junk in your init.m file, then next time you start the kernel, you will get an error message. Then you have to hunt down where is that file and remove it. Same thing happens with these persistent values. If you put something there that you shouldn't, then the system may behave badly. And so one important test case is just use kernel persistence, and then you just quit the kernel and everything, all your sins will be forgotten. The next level of persistence is the front-end session. Values stored in the front end are visible to all kernels running under the same front end, and the lifetime is a single front-end session. In particular, these values will survive a kernel restart as long as the front end is still running. So that's a way to remember something from one kernel invocation to the next. And again, if you mess up, just quit the front end, and then these values are gone. And how do we do this? Well, the front end session supports the notion of setting options. So I can set the options in my front end, and then I can look at those, and that's how they are stored. And if I'm not doing it here, quit and restart the kernel, this value would still be around because I have not ended the front end. In a similar notion, the notebook document itself can be used to store persistent values. As a value stored in a notebook is visible to that kernel that is connected to the notebook. I mean, you know how our system works. We have the front end that I'm using here for the presentation, and this particular notebook document that you see here is connected to a kernel that does all the computations that I've done so far. And so these persistent values will be visible to that particular kernel. And the lifetime now is the same as the document. And it's exactly the same as before. You can set an option in your evaluation notebook, and you can ask for it. Now, the interesting thing about this location is I can now send this notebook to somebody else by email, and At the other end, if you open that document, those persistent values will still be there because they are right inside the notebook document. So this is a very useful persistence location. I should say that at the moment, you shouldn't try to store megabytes of stuff inside the notebook. This set options technology is limited to small values. We are working on a new way of storing bigger stuff inside notebooks because we have realized that this is very useful. I mean, it's now routine to generate large amount of data like audio capture or video capture, or you do big computation and you want to save the results so that the next time you open the notebook, you don't have to redo the computation. So we are working on some more efficient storage technologies. The next level up is the local object. Local objects have been around for, I think, 2 versions. They are a generalization of symbols. We call them local symbols. They work the same, so you can store a local symbol, you can ask for the value, and those local symbols are actually backed in your home directory. There is a directory where they are stored, so you can see whether it exists, and you can remove it. The scope of these local objects is your login domain or any accessible file system. And the lifetime is as long as your hard disk lasts. And of course, if you have backups, then it will live on forever. The next technology, the cloud object, we have cloud symbols, just the same as local symbols. They behave exactly the same. Now, the only difference is that it will take a few milliseconds to ask for a cloud object because that is stored somewhere on a remote machine in the Wolfram cloud. And so the scope of these cloud objects are your cloud login. So if you go to a different place, log into the same cloud, you have those cloud objects back, which is the difference to the local objects, which if you go to a different computer somewhere else, you don't have access to those. So these are the storage locations that we currently support, from the very short-lived one to those local objects, cloud objects that live forever. And you can now you see, I mean, the syntax is almost the same, but here you say local symbol, here you say cloud symbol, or before we had just symbol, or you have to use set options. You shouldn't have to remember all of this. So we designed a unifying layer on top of these technologies, namely the persistent value, so you can use the same syntax for all of those. This is just a recap of those persistence locations that we have talked about. Kernel Session, that's the name for the ones that live in the kernel. Frontend Session, Notebook, Local, Cloud. Now there are some additional ones like Local Shared. If you install Mathematica on your own computer, then there are 2 locations where you can put stuff. One is in your home directory, and the other is in a shared directory that is visible to everybody who uses the same software installation. And so the idea is here you could put values that everybody in your organization should be able to see. But it's just another form of local objects. And then there is another hidden location, the installation location. That is where you can put defaults for your persistent values. We will see examples later on. And obviously these 2, local shared is usually read-only. To populate them, you would have to become super user, and then you can write to the shared location. So how do we now use these persistence locations? So the main use is for persistent values. Persistent value has a name and a default location where it is stored. This default location is the persistent space, and the default is local. So this will turn into a local object, a local symbol, That's how you use it. But of course, you can specify where you want to put it. So you can give a second argument to persistence value where you can specify any of the persistence locations. So this particular value, again, and you see here I use the same key, so I create persistent values under the same name. I put one in the kernel session, I put one in the front-end session, and I put one here in the default location, which is, as we saw, the local location. Now what happens if I ask for that persistent value? Well, why does it give me this particular one? Well, the reason is that it searches all these locations in a given order, and the order is given by the persistence path. So it searches the kernel session first, and that's why I get the 41 down here. Then it goes to the front-end session, local, local shared, and installation. Note that the cloud location is absent from the default persistence path. Depending on where you live on this planet, the cloud location will mean several hundred milliseconds delay for each access. And we did not want to make kernel startup slower by that amount of time by default. So it will take a deliberate effort to put the cloud location there if you want to use it. I will show you how to do that later on. So by default, persistent value finds the first value along that path. Now, you can actually tell it how it should deal with all those values that are present. Now, the merging function is an optional argument of persistent value. It will receive as its argument the list of all the persistent values that are actually there. And you can see we defined 3 of them. So the merging function receives the list of these 3 values, and if I use the merging function identity, I will simply get back that list of all the values that you have. And the default merging function is obviously, as you have seen, first, so it will give the first value. That implements that hierarchical lookup where you can put default values in your local objects. And if you need to change something for a certain time, you can override that by putting something into the front-end session. And when you quit the front-end, that value is gone, and you will be back with the default value. This is the intention of this system.
Roman?
Yes?
This persistent value where you get the list of persistent values, now I presume that that's ordered, the 41, 40 through 43 goes in that order, somehow related to the same way persistence path is ordered.
That is exactly the order of locations in persistence path.
Okay, so now, but how, it seems inconvenient a little bit that I can't tell which of those persistent locations have a value from this result and which, you see what
Yes.
I'm saying?
I mean, of course you can. I mean, just wait a few minutes and I will tell you how to do it. Because obviously, just as with symbols, you need a way to do housekeeping and see what is available and how to delete those values in particular. So there's a lot more to come. This is just the way you would normally use it, and you will see in a minute how you can actually see which values exist. Now, this merging function is quite versatile. Here's another example. I've defined 3 values for that particular persistent value in the kernel session, front-end session, and local. And all these values are lists. And as we have seen with the merging function identity, you see all of them. But you could also use apply join as the merging function. And that would join those values together. You still see the sublists down here. It will just join the outermost level. Or if you really want just or everything, you can also use flatten, and that will just give you all the list of the innermost parts of those nested lists. And you can even do more fancy merging with persistent values that are associations, because there are ways to merge associations in various ways. This is particularly useful for storing preferences, where you have usually your own key value store. You use an association with all the user settings. So now, as we have seen, the persistent values live in persistent objects, and here is that answers your question. Persistent objects given a key will give you all existing objects in all the locations on the search path. So now I know that there is one in the kernel session, there is one in the front-end session, and there is one local one. And the most important command here is delete object, which will get rid of all of them. So now, if I now ask for those again, they are gone. You can also set your persistent values to expire. Here I set one to expire within 5 seconds, and I will immediately after doing that run these 3 lines here. So it will give you that value, then it will wait 5 seconds, and it will again ask for the value, and it says, well, the value is not there anymore. This is a relative expiration time. There's also an option to give an absolute. I could say this object should self-destruct at the end of this year. Now let's look at the main use for these persistent objects, and that is for initialization. So there is one more thing to learn. It's called initialization value. Initialization value takes a variable as argument, and you assign a value. Now this setting, this initialization value equals 1, does not set that variable to the value 1. It remembers an initialization. And to actually perform the initialization, you can either say initialize that variable, as I've done here. Now it has been initialized. But most of the time you will use that to have the initialization happen automatically at kernel start, which I will mention in a few minutes. Now the initialization values work the same way as the persistent values, so there is the optional second argument of persistence base and persistence path. Now, of course, the lookup along the path becomes very important because you can set a global default value for the variable and you can override it by choosing like the notebook location or the front-end session location to temporarily change the lookup values. And as before, these can be found. Now the initialization values are persistent values. They are just use, let me show you, this is very long, so let me show again the names of these. So the initialization value of a variable turns into a persistent value whose name is system session followed by the full path name of the variable. So here you can see the one that I just put up on the screen. And so the result is a persistent object that lives in a certain place. And here I'm asking for all the initialization values. You see the one we just put up here, but there is lots more. But all of these live in the installation location. These are defaults that have already been set up. Obviously, we use this system for setting defaults for all the particular objects like persistence base and persistence path itself, of course, can be initialized. So that, of course, will then require a certain order in which these happen. And there is initialization and initialization context, which I will mention in a minute. So there's a lot of stuff here, but the only thing you put yourself is this one. But it's always important to know how to find all of the ones that exist and perhaps delete them if they don't do what you want them to do. So now we have all the technology for initializing kernel in this new way. The way it works is when the kernel starts, it will perform initialize all, which will then find all existing initialization values. And for each variable for which there is a value, it will initialize that variable. Now that alone is not terribly exciting, but some of these variables then have special meaning, like $initialization, which after having been assigned a value, will then evaluate its own value. And so that's the replacement for the init.m files. You can put code into the $initialization variable that will happen every time you start the kernel. I will give you an example in a minute. So let's look at some interesting ways to use this new technology. First of all, as I've said, the cloud location is not part of the default persistence path. Now, if you live close enough to the cloud server, and that cloud could very well be your own private cloud, in which case you will live close to it, you can change that. Now, what do I have to do? I have to change persistence path. So I can use an initialization value for persistence path. And I have to put it somewhere, and I cannot put it in the cloud because that's not yet on the path. The most useful place is a local persistent object, so that will from then on, every time you launch a kernel under the same username, look up that new setting. Let me do that here. Let me now quit the kernel. And let me evaluate this variable and thereby starting a new kernel. And hopefully, yes, there it is. And so now you can see the cloud location is now on the persistence path. The cloud location is a cached location, which means that once it has found the value, it will keep a local copy so that it minimizes the communication with the cloud, which can take time. Now here we are as close to the cloud itself as possible because it's actually in a computing center right in the city, so you can't get any closer than that. So what we've done is we've defined an initialization value for persistence path, and then whenever you start the kernel, it will find that value because it's local on this machine, and it will change the setting of persistence path. And then it will use this new setting of the persistence path to look up all the other initialization values. So now you can put initialization values in the cloud location. Yes?
So the installation is added automatically?
That's always at the end, yes.
Okay. So could you skip the others too? Like could you skip local shared and it would be also automatically added?
No, everything else, I mean, you can of course remove that if you don't need it.
Right, but I mean it will not be automatically.
No. The other one, installation is, the reason is that it contains defaults, and by always putting it at the end, when you look up a value, you know that you will always have the default. That saves you an if statement to see if there is a value otherwise. So it's just the fallback at the end. Another use of initialization values is with an extension to the function once, which you may have encountered. It's a 11.1 new feature. Once takes normally one argument. The argument is typically a very long computation that does something and returns a result. And before that would simply store the value of that, the result of that computation inside your kernel, and so when you then invoke once again, then it will not redo the computation because it has already done it, but it will look up the cached result. And now you can use different persistence locations as caching locations. This is the most interesting use case. So what will happen if I evaluate this? See that I put this in an initialization cell, which you normally put at the top of your notebook. What happens if I evaluate that initialization cell? Well, I haven't done this computation before, so you would see that it actually performs that computation and then returns the result. Now, if I do this again, It will not redo the computations, but return the old result. And moreover, this result is cached inside the notebook. So even if you send that notebook to somebody else by email, if I receive such a notebook and I will do this initialization cell, it will use the previously cached result. So this is how you can avoid recomputing things which take a long time to do. Now, of course, these values might accumulate inside your notebook, so here's how you remove them. The result of once is stored as a persistent object, so you ask for all persistent objects inside your notebook. At the moment there's only one. There is the result of that. It hashes the input. Obviously it needs to find it, so it hashes the input, and you can just delete that, and then it is gone from your notebook document. Now another useful case for persistence and initialization is setting up an environment in which you can debug new code, but an environment that will go away after you are done, and so you don't forget to change back all the values that you changed. So let me do the following. So I'm using the Frontend Session for this purpose. This is very useful for this purpose because it allows you to quit and restart the kernel and still have your special environment. But when you're done or when it doesn't work, you just quit the front end and then everything is forgotten and you have a clean slate again. So I set an initialization, and initializations, I'm sorry, sometimes the mouse, the initializations should be held expressions. These are the things that will be evaluated when the kernel starts. So what I want to do is when the kernel starts, it should add a certain directory to your path. That's where your code lives, which you are debugging right now. And you also want to read the package that is under development. And so you add that package to the $initialization context. So these are both initializations. Let me do that. Now I quit the kernel, but not the front end. Now I ask for $path, which will start the new kernel. And hopefully the new directory is on the path. The context path contains that particular package that I mentioned. Let me show you, hopefully on the same screen here, my package. And that package has been read, so if I ask for all the symbols in my package, there's just one that is now available. So you can very quickly turn around in your debugging session, you try out things, change the code, quit and restart the kernel, and you are back in action within a few seconds. And if you're done, you just quit the front end and everything will be gone. We've talked about merging functions before. You can equip certain initialization values with your own merging functions. The way to do this is when you set up an initialization value, you also specify the default merging function. So here I set the default value for this variable to be the empty list, but I also set the merging function to be flatten. If I now specify a second value for this variable at the front-end session location, and if I ask for that value, it will flatten the two values found. Now this one obviously doesn't contribute anything, it's a good default, the empty list. And this will now happen automatically. So every time you start the kernel, your variable will have that particular value. So this is useful for values like we've used before, lists of things where you don't want just the first of them, but you want all of them. And so you use a default merging function of flatten. There are a couple of already defined custom merging functions. And now I'm turning to this installation location with the defaults, there is one good example. That's the system variable $assumptions. $assumptions has an initialization in the installation location. Now, what does this contain? Well, it at least contains a default value, but if I now look at the underlying persistent objects, there is a hidden way persistent objects behave like functions or like databases. You can ask for all its internals, and most of those are internal. You should not mess with those, but you can probably guess what they do. Now here you see that default merging function. The default merging function for assumptions is AND, because assumptions is a collection of Booleans. And so if you have several of them, the natural way to combine them is to AND them together. Not to give a list of them, but to AND them together. And you can also see that the value, the actual default value, there isn't one, because the default value says inherited, which means don't change the value, just use the special merging function. You can also see when these were created, who created them. Now this is a built-in default, so there's no information here. The expiration date, if you set one. There's another thing called the value preprocessing function, which allows you to make sure that only legal values are assigned to a variable. And it will also record the version of the language at which the value was done, so that later on we may be able to migrate all the values to new systems. There's yet one more thing, namely the so-called evaluation environment. Now, session means what I'm doing locally here, front-end, kernel, or in the cloud front-end, kernel. But there are other types of kernels. For example, there are subkernels which are used for parallel computing. And I can set an initialization value not only for my own types of kernels, session kernels, but also for other kernels. So here I set a default value for time zone. I store it locally, but not for myself, but for subkernels. If I now launch 2 parallel subkernels, then my own time zone is -5, but the time zone of those parallel subkernels is 0. And how do you find all those values? Well, let me ask for all initialization objects here, local cloud, but not for myself, but for subkernels. So that's the one I just defined, and delete object will get rid of it. And in the future, it will also be possible to set up default values for your cloud computations from your desktop. The current cloud version that is deployed in the Wolfram Cloud does not yet support persistent initialization. That's still under work, but within a few weeks there will be a new version that will support it. But you can already now use the cloud persistence location on the desktop, but not yet on the cloud. Now, as with everything that is persistent, I mean, the kind of case that everybody's familiar with, you have a long session, you work on something, you define some variables, x equals 5, y equals 17, and then an hour later, you use something that involves the variable x, like to differentiate with respect to x. And then you differentiate with respect to 5, because you forgot that an hour ago you defined the variable to be 5. That's the kind of persistence problems that you already know. Now, of course, it gets even worse, because you can have persistent values all over the place. And so the equivalent of the magical clear all of global, which all of you know if you work hard enough with notebook documents, is just to ask for all the initialization objects. And in particular, I ask for all of them in all the writable locations. That excludes installation and local shared. And I have a couple of them. You see, you remember this one. I worked with this one. I worked with this one. But the magical thing here is just to say delete object, take the values of all of these lists of values and delete them. And now if I ask for all the initialization objects again, they are gone. So this is how you clean up. And and of course what's missing now is some nice, let's say, front end to that persistence system.
So you now deleted the persistence path too?
Yes, now of course, the next time I start the kernel, the cloud location will no longer be there.
Right now in this kernel, so you will not be able to add anything because the path is missing?
No, there's of course a default.
Oh, the default still works.
The default, you cannot change, you cannot delete the defaults. No, you cannot shoot yourself in the foot. I mean, that's that default location is there for exactly this purpose, so that all of these variables are guaranteed to have a working value. All you deleted was your overriding of the default value. So if I now quit and restart the kernel, the cloud location.
Query persistence path now, so it will have that default value, right?
Well, not in the current kernel. I haven't changed anything. I just changed the initialization of the next kernel that I will start. You see that it's always one kernel later.
Right. Okay.
So like when you write an init file, you have to quit and restart the kernel to actually see the effect of that init file. Now, the other useful thing to do is to, if you are still unsure about the effects of some things you do, just set persistent space to Frontend Session. And of course, you can also do an initialization that is just stored in the Frontend Session. And these things will work normally for all the kernels that you start under the current frontend, but once you quit the frontend, it's gone. And you have a clean slate again. So that's a very useful thing. And of course, you can also put the special setting of persistent space as an initialization itself into the front-end session. I should probably have mentioned that. But I mean, you can just use initialization value of persistent space, comma, front-end session equals front-end session. So that would perpetuate that for your front-end session. So this is the kind of things you can do. Okay, sorry, that is internal stuff. That's in fact the end of the examples section. So to recapitulate, persistent values are stored in persistent objects. Persistent objects are stored in any of persistence locations which vary in their degree of persistence and visibility. And the main use for these persistent values is as initialization values and as preferences for your packages. This is a new technology that is in 11.2 on the desktop. So maybe it's not 100%, it's marked as experimental because it does change the way the kernel starts, right? I mean, we have to understand that this is a fragile part of the system. If you put an initialization there that computes something which takes 10 minutes, then your kernel startup time will be 10 minutes. And if you did that without realizing that you did that, it's even worse. So that's why I've always, at the end, put in the commands to find all values and to delete them. And of course, I mean, as I said earlier, we will in the future have some ways of manipulating this more easily, like having a notebook that lists all the values. You can click on them to delete them, you can change them, and so on. So there would be a nice user interface for this new technology. But at the moment, it's important that it's out in the wild, that you can play with it, that you can use it, and also give us feedback. Thank you.